Good evening, everyone. What a perfect opportunity, right? 5:10, end of the last session of the, I will say, first day, and which is holding you between your cocktails, and the topic is zero knowledge proofs onto that. So I promised Steve that we'll be on the spot, but before I begin, a lot of thanks to James. I've spoken at a lot of conferences, but really I have seen that organizers are taking care of everybody out here onto that. So big hand for that guy who's actually translating everything. And let me tell you, this is not scripted. He doesn't have a script. He's doing on the fly. Okay, so hats off to you onto that. So quick introduction, Rajan Behal, I'm Managing Director in KPMG, has been in this space for about 19 years now. Yeah, I'm old, but not Karla. So I'm joined by my colleague, Dr. Karla Clarke. So I will hand it over to her. She will introduce, walk you through some slides, and if she is kind enough to give it back to me, I will prefer to cover some slides and maybe take up some questions from you guys. So trust me, you are in the safe hand. Karla.
Thanks, Raj. All right, so like Raj said, we'll keep this fast. I mean, we're standing between your drinks. Don't want to be that person. My name is Dr. Clarke. I'm with KPMG, Cybersecurity Services. And I've been a practitioner / theorist, I like to call it, for the last 7 years now. At the end of the day, fun fact, I live in Los Angeles. Most people are like, you know, what is it that brought you there? Why do you love it so much? One thing, just the mountains. That's simply why. And why I moved all the way to the West Coast was saw some mountains, liked them, was like, I gotta live here. So yeah, zero knowledge proof, let's jump in. Privacy preserving digital identity. Now, I wanna jump into exactly what is zero knowledge proof before we start. I'm gonna keep this very simple. It is late in the afternoon, and this can be a overly technical and cumbersome topic. So zero knowledge proof is simply put encryption. And even simpler than that, encryption is just math. So basically, zero knowledge proof allows us to identify any information, trying to keep it simple, present data, identify what that data is without actually sharing information about the data. So you're basically replacing that knowledge with knowledge about knowledge, if that makes sense. All right. So the importance of ZKP. ZKP is growing in our current security space because of the increased breaches that we're facing within various organizations. Every single session today started with some statistic about how security and privacy is pertinent to our organizations, and every day there's someone trying to attack and obtain more and more information in order to monetize that data. So zero knowledge proof allows you to secure data without actually sharing any information with the verifier. So I'll go more detail into that in our privacy preserving digital identity model. So if you guys can follow along here, this model is directly from NIST 853, and that is the digital identity model. The key aspect of the privacy preserving portion of this model is ZKP is the authentication method that is leveraged in order for the CSP in order to prove or obtain the attributes from the verifier. So that claimant is able to basically allow information to continue to flow to the verifier and authenticate or obtain an authenticated session without actually sharing data from the CSP. So ZKP is just your authentication method that's being leveraged within this model. Practical application. We've broken this out into 6 categories that we're going to quickly walk through today. And basically, I'll cover the first 3, and then I'll hand it over to Raj. So we have authentication, messaging, and secure sensitive information. So I'll start there. Authentication. Authentication, we can basically ensure passwordless or leverage ZKP in order to enable passwordless authentication by basically storing the password but never sharing the password. If you have your prover and your verifier here, there's simply 3 steps to break this down. The prover can declare their identity and request authentication from that verifier. That challenge is then sent back, and in response, the verifier is able to compute the challenge without disclosing the secret. So basically, a computation is done on the back end in order to allow the prover's identity to be verified in order to allow that authentication or that authenticated session to continue forward. Messaging. Now, this is a really big one because a lot of what we're doing every day involves sending information back and forth using our different messaging applications. So a great way to secure messaging is you can leverage an encryption algorithm like Diffie-Hellman and ensure that you're able to solve a simple problem here, like using the public key. A user encrypts the message, and then the private key is generally used in order to decrypt. And the owner of the private key would be the only one who can decrypt that message, but anyone knowing that public key could send them in privacy. I think I have a small thing there, but basically what we're trying to get to here is by applying this authentication method, when it comes to your messaging or securing messaging, you can ensure that the block of the message is encrypted in order to basically make sure that an outsider is not able to intercept that message and leverage the data in a malicious manner. Securing sensitive information. So here's a fun and interesting one. A lot of our most sensitive information lies within banks. And in order to secure that information within our banking systems, we can leverage ZKP by, let's take, for example, a bank statement. There's quite a bit of sensitive data within that statement. Instead of encrypting the entire bank statement, you can encrypt certain blocks of data within the bank statement. So for example, you call your bank provider and say, I need XYZ information. Instead of the person on the phone being able to access all of your data, they can then access just blocks of information as the rest of the information within has been encrypted. ZKP is allowing in the back end, if they're just requesting, let's say, salary information, that person can type what they need to, you prove who you are, whether it's, what was your first car or something of the sort, and then be able to realize, okay, this person knows enough that they are allowed to view this sensitive information, and just that block of information will be presented to them in order for that authenticated conversation to continue forward. All right, storage protection. Raj.
Thanks, Karla, for being kind enough to hand it over back to me. Sorry for this. Okay, so I'm going to tell you a story. Yesterday, I checked into the Marriott, right? The moment I checked in, they gave me a key, right? Now I have my valuables, which are stored right there in my hotel room. The challenge which I face is the hotel reception still has a master key, right? So what I'm trying to do is I'm trying to trust the hotel that while I'm away, right, they will safeguard my valuables onto that. So, but that's not a privacy to me. Privacy to me is not a trust issue. I know that prior to me, the guy from the MIT, the professor was kind enough to do a lot of talking onto the trust. But for me, privacy is more than trust onto that. So the way I believe is that I should only have the copy, it should not be available to the hotel reception or anybody else. So what if we change the scenario a bit, that instead of me getting a hotel key from the hotel, if I would have carried my own lock, okay, I check in, I authenticate, authorize myself to the reception, and then they let me put my own lock at the door of the hotel room, right? That way, what happens is, there's nobody other than me who can actually get into my data. That's what the GKP allows us in the case of the storage protections onto that. So basically what we do is that there are a lot of cloud storage services which actually enable these type of solution nowadays, right? Especially when you go for a SaaS solution. The challenge you face is your data is hosted into a third party. Even if you use a bring your own key, right, BYOK, the challenge is at some point of time you hand over your key to them to do the encryption and decryption, okay? So what if instead of handing over a key to them, there should be a mechanism where I can authenticate and then provide the key which can decrypt on the client side encryption side and upload the data to that. So what happens, we have seen the litigations, right? Microsoft there's actually litigation right now going on in the Supreme Court, which is going to change this entire SaaS world a lot. So Microsoft is being sued, subpoenaed actually, to provide a data, which is in Europe actually onto that, right? So what if I can create a scenario where even the storage or the cloud provider or the service provider, even if he shares the data, he has no mechanism to decrypt it. Then the actual privacy kicks in there. So there are a lot of organizations, there are a lot of solutions right now available which basically use this zero knowledge mechanism to do the encryption and decryption in such a way that keys are never transferred back to the service provider. So that's a very typical use case for the storage protection. So data sharing. Actually, IBM is doing a lot of work onto that. Karla talked about encrypting only blocks instead of encrypting the entire data, and then only sharing a set of the blocks so that at any point of time, there's no way to get to know the encryption key and decrypt the entire file at one point of a scenario onto that. So IBM has come up with a blockchain hyperledger. Basically what they are doing is they are using zero-knowledge proofs to transfer asset. The typical challenge which we face is, let's say if I go to a bank or even if I go to a mortgage company, right? There is a closing organization which is involved, right? Which actually the title company gets to know that what a buyer is selling, what a purchaser is actually, what a seller is selling and what a buyer is actually getting. So the actual asset is known not only to the buyer and the seller, it is also known to the intermediary transaction or a settlement system onto that. So IBM has come up with a blockchain hyperledger where they are using identity mixer by using ZKP. They have developed a protocol called JK80, where there is actually zero-knowledge asset transfer, where you can actually make it asset transfer without disclosing the nature of the asset. The only thing which you actually disclose is that asset has transferred from a buyer to a seller or seller to a buyer. But the actual asset, which asset, whether it was dollars, whether it was a house, whether it was a boat or whether it was a bicycle, that is never recorded or never made aware to the transaction system onto that. So yeah, another application of the ZKP. Typically when we encrypt the files and we upload the encrypted files also, the metadata about the files is never encrypted. So the storage provider still knows that it is what type of data which you have actually uploaded there, which you are storing. So just imagine if you can design a system where not only the file system, the file, the content, the data is encrypted, but also the logs about it, also the metadata about it is encrypted and is not known to the storage provider. So I have listed out there, EncryptFS is it's actually a protocol, not a solution. It's a file encryption based system which has been designed leveraging the ZKPs actually, where you not only encrypt the data, but you also make sure that the metadata is also not available to the storage provider. So it is only you who actually know what the data is and the way it is encrypted and stored into the cloud provider. So I will quickly run through the ZKP technology landscape. My apologies, I was not allowed to use logos due to obvious reasons. But the thing which I want to point out is ZKP is not new. It has been around for last, I think, 1980s, late 1980s it started. So it's not a new technology, but it has not made much progress because of some challenges which we will discuss. But now if you see, there are big players like Microsoft, IBM, which has started betting in this space, which has actually now started getting a lot of traction because the computing power has increased, the cost of the implementation has come down for the ZKPs onto that. So few considerations if you are actually going to apply ZKPs in your organization. There are a lot of protocols, there is a lot of research which has been done, which protocol to use, make sure that whatsoever mechanism which you use, it is transparent, okay? The clients, the same mechanism can be applied to your file system, the same ZKP can be applied to your IoTs, the same can be applied to your HMIs, human machine interfaces onto that. So it has to be universal, right? Make sure that you are compliant with all the Z-Star standards which are coming up right now. Then ZKPs can be interactive and non-interactive. What I mean by interactive is when a human user is using it, there are non-interactive and Z-Stars, there are a lot of algorithms on that line. So make sure that machine-to-machine interaction also uses a ZKPs onto that. The thread model is very important, especially with the computation power getting increased. Even the power by which the people can brute force and attack your algorithm is also increasing a lot. So you have to take care of your thread models onto that. And last but least is the quantum. We are approaching a era where the encryption is going to be challenged by the quantum. And that's another couple of years, I think, if not less, away from the reality onto that. So you have to make sure the protocol or the implementation which you are actually implementing is post-quantum secure. So some challenges of the, I will say not challenges, I will say those are the opportunities which actually the technology has now enabled us to better adopt the GKPs onto that. It has been a, when you say GKP, right, you generally think that, okay, these are the technical nerds who knows the encryption and mathematics a lot. That's why they are trying to go get into this technology onto that. Those are the days of past. The protocols has evolved. I can list down at least 12 to 13 protocols which are right now in place, and especially with the Z-Star protocol, the competition has come down. The competition requirement for this has come down, so it has become viable to start using it onto that. So there was a time when you used to require a very high-skilled resources to use GKP. That is no longer true. Now you can actually get these skills are available. These are actually very well taught courses into the our education system onto that. So what do we want you to do? So as a takeaway, what we will say is go back to your organizations, try to see where you can actually come up with the use cases where you need to preserve privacy, and take it a step further and try to see what are the different products available in the market, do a technology landscape. We have given a lot of references in the appendix of this last slide of this presentation, which can point you to a different resources where you can elaborate and get to know about the technology landscape. And we will strongly encourage you to do a POC and see whether it is relevant to your organization and whether it is a commercially viable solution you want to adopt in your organization. So that leaves us about 5 minutes for the questions. We are going to hang around even after that. We will be at the welcome reception also, so feel free to ask any questions, and Karla is always ready with the answer. No, that was the joke. I will take the questions. Any questions?
I think we're good. Awesome.
That's good.
Oh.
Oh, go ahead.
So, from a commercial enterprise point of view, what are the barriers to adoption?
Okay. So I would say there is a barrier from the commercial side of the view. It's more of a perception issue right now. Because it used to be tough. Okay, you need to, you used to require a lot of computation power for GKPs. But now even the cell phone, the iPhone which I carry, has a lot of processing power. The basic purpose of ZKP is it's end-to-end encryption, with nobody actually knowing what exactly are the keys onto that. So that means you have to start encryption from the right endpoint. So your endpoints has to be viable enough to compute that encryption algorithm and then send the data across. So I don't see any challenges right now, but I will say it's more of a mindset and a perception adoption issue. Blockchain has changed it a lot. See, and if you have to have privacy over blockchain, whether it's a public or private blockchain, you will be actually slowly pushed towards I will say ZKPs. That's the no-brainer solution for me. So if your organization is trying to adopt blockchain, you will be naturally pushed towards ZKPs onto that. So I will say it's more of a mindset and education, which is not there. But from the resources point of view, I don't see any challenges here.
So how would you use ZKP for username, password login?
Okay, so actually that has been there behind the scene a lot. If you see PKware, okay, there used to be a library PKware which used to be, I'm not trying to say how old I am, but there used to be a library for that. It used to use actually a similar version of a ZKP. So what basically you do is, instead of sharing the password, I'm gonna answer a series of challenge and response questions back. Let's say if I'm going to authenticate to Karla, she's gonna ask me 10 and 20 questions and answers, which are different from the password, right? In a very layman world, you can call it challenge response questions and answer, to establish a trust that yes, I'm the right person onto that, right? So the more the number of the questions, the more I will say the trust will be higher onto that. So that's a deterministic thing for Karla to say, okay, after 10 questions, yeah, this is good enough for me to let you in onto that.
Yeah.
So that's a process.
To add to that, the last session we did on ZKP, we actually did a quick demo where we had 2 people come up and show how simple it is to establish trust by challenge and response. So like Raj was saying, like in the back end, it's really the mathematical computations that are occurring continuously. And every time a question is answered correctly, that level of trust is built and increased until that secured connection can be established. So it's, if you're saying username and password and you type in your username and I have, you have your password, I don't know the password, I'll keep challenging you with questions that would tell me you actually know that password without actually sharing that password with me, except it's math.
So we actually did a bigger version of this session at RSA. If you search on the net, you will be able to find the recording of the same, where we actually did a live demo.
And it was way more detailed, so you can dig in more.
Any other questions?
I saw another hand. We have 44 seconds.
Go ahead.
Oh. No?
Any questions?
You put him off.
Oh, man. That's a hard thing for Karla to do.
All right, I think we're good. Thank you, everyone.
Thanks, guys.